Introduction. Look son, this is Qutub Minar. You know how high it is? No. Okay, I will tell you. It is 72.5 meter tall. How can we find the height of any building? We can find its height using trigonometry. It is a branch of mathematics used to measure the sides of a triangle. Okay, can you tell me more of this? Yeah, sure. In this lesson, you will learn how to solve geometrical problems including triangles. Objectives. At the end of this lesson, you will be able to measure the angles in degree and radian, convert the angles from degree to radian and vice versa, solve geometrical problems using trigonometric functions, solve trigonometric equations. Angles. What are the angles? Let a revolving line starting from OX revolves about its endpoint O in a plane in the direction of arrow and occupies the position OP. Then it is said to trace out an angle XOP. Here, OX is called the initial position and OP the terminal position. The fixed point is O is called vertex. An angle XOP is said to be positive if it is traced out by a line revolving in the anti-clockwise direction and negative if it is traced out by a line revolving in the clockwise direction. Angles. How to measure the degree. Degree is used to measure the angles. 1 degree is 1/360th of a revolution. 1 degree is divided into 60 minutes. That is, 1 degree is equal to 60 minutes. 1 minute is divided into 60 seconds. That is, 1 minute is equal to 60 seconds. There are 360 degrees in one full rotation, one complete circle around. A full circle is 360 degree. Half circle is 180 degree. How to measure the radian? Radian is the angle subtended at the center of circle by an arc whose length is equal to the radius. Let O be the center of a circle of radius r. Cut off an arc AB is equal to r. Then angle AOB is equal to 1 radian. The circumference of a circle of radius r unit is 2 pi into r. Thus, one complete revolution of the initial side subtends an angle of 2 pi radian if radius is equal to 1 unit. If we draw an arc of length L, it will subtend an angle which is equal to L by r radian, where r is the radius of the circle. And we can write it as L is equal to r into theta. Angles. Relation between radian and real numbers. Radian measures and real numbers can be considered as one and the same. Relation between degree and radian. 2 pi radian is equal to 360 degree. Pi radian is equal to 180 degree. The value of pi is 22/7. We can find that 1 radian is equal to 57 degree 16 minutes. And 1 degree is equal to 0.01746 radian. Example. Express in radian the angle of a regular octagon. Solution. The sum of interior angles of a regular polygon of n side is equal to 2n-4 right angles. Interior angle of a regular polygon of n sides, 2n-4 by n right angles. An octagon has 8 sides. Interior angle of a regular octagon is equal to 2 into 8-4 whole upon 8 right angles. 3/2 right angles is equal to 3/2 into 90 is equal to 135 degree. 180 degree is equal to pi radian. 135 degree is equal to pi by 180 degree into 135 radian is equal to 3 pi by 4 radian. Example. Express the angle minus 37 degree 30 minutes in radian measure. Solution. As we know that 180 degree is equal to pi radian. Given angle in degree is minus 37 degree 30 minutes is equal to minus of 37 plus 30 by 60 is equal to minus of 37 plus 0.5 is equal to minus 37.5. In radian, it is expressed as 1 degree is equal to pi by 180 radian. Minus 37.5 degree is equal to minus pi by 180 into 37.5 radian is equal to minus pi by 24 radian. Trigonometric functions. Let a revolving line starting from OX trace out an angle XOP is equal to theta in any of the four quadrants. Let M be the foot of perpendicular from P upon X dash OX. Regarding OM and MP as directed lengths, the ratio of OM, MP and OP with one another are called circular functions or trigonometrically ratios of the angle theta. Let OM is equal to X, MP is equal to Y and OP is equal to R. R is greater than 0. We define the various circular functions as follows. MP by OP is equal to Y by R is called sine of theta, written as sine theta. OM by OP is equal to X by R is called cosine of theta, written as cos theta. MP by OM is equal to Y by X. X not equal to 0 is called tangent of theta, written as tan theta. OM by MP is equal to X by Y. Y not equals to 0 is called cotangent of theta, written as cot theta. OP by OM is equal to R by X. X not equals to 0 is called secant of theta, written as sec theta. OP by MP is equal to R by Y. Y not equals to 0 is called cosecant of theta, written as cosec theta. From the definition of T ratios, we have cosec of theta is equal to 1 by sine of theta. Sine of theta not equals to 0. Sec of theta is equal to 1 by cos of theta. Cos of theta not equals to 0. Cot of theta is equal to cos of theta upon sine of theta. Sine of theta not equals to 0. Tan of theta is equal to sine of theta by cos of theta. Cos of theta not equals to 0. Trigonometric functions. Three fundamental relations of T ratios. Sine square of theta plus cos square of theta is equal to 1. Sec square of theta is equal to 1 plus tan square of theta. Cosec square of theta is equal to 1 plus cot square of theta. If sine of theta is equal to 0, it means that theta is equal to n into pi, where n is any integer. If cos of theta is equal to 0, it means that theta is equal to 2n plus 1 into pi by 2, where n is any integer. Trigonometric functions. The three basic trigonometric functions have following values. Trigonometric functions. There are four quadrants as shown in the figure. In the first quadrant, all are positive. In the second quadrant, sine and cosec are positive. In the third quadrant, tangent and cotangent are positive. In the fourth quadrant, cosine and secant are positive. Simple rule to remember. After school to college. In above rule, A stands for all, S stands for sine, T stands for tan, and C stands for cos. The reciprocal of these ratios are also positive in the respective quadrants. Trigonometric functions. In the table given below, the signs of all the T ratios are given in each quadrant. Trigonometric functions. Domain and range of trigonometric functions. As we have studied earlier, that angle can be considered as a real number, so we denote the angle by x, not by theta. Sine function. Range for sine function is -1 and 1. Sine function holds for all values of x, so its domain is set of real number r. Cosine function. Range for cosine function is -1, 1. Cosine function holds for all values of x, so its domain is set of real number r. Tangent function. Range for tangent function is the set of all real numbers. The domain of y is equal to tan of x is the set. X belongs to real number. X not equals to 2n plus 1 into pi by 2, where n is any integer. Cosecant function. Range for cosecant function is the set. Y belongs to real number. Y greater than or equal to 1 or y less than or equal to -1. The domain of y is equal to cosec of x is the set. X belongs to real number. X not equals to n into pi, where n is any integer. Secant function. Range for cosecant function is the set. Y belongs to real number. Y less than or equal to -1 or y greater than or equal to 1. The domain of y is equal to sec of x is the set. X belongs to real number. X not equals to 2n plus 1 into pi by 2, where n is any integer. Cotangent function. Range for cotangent function is the set of all real numbers. The domain of y is equal to cot of x is the set. X belongs to real number. X not equals to n into pi, where n is any integer. Example. If sec of theta is equal to under root 2 and 3 pi by 2 less than theta, which is less than 2 pi, find the value of 1 plus tan of theta plus cosec of theta by 1 plus cot of theta minus cosec of theta. Solution. Sec of theta is equal to under root 2. Cos of theta is equal to 1 by sec of theta is equal to 1 by under root 2. Sin square of theta is equal to 1 minus cos square of theta is equal to 1 minus half is equal to half. Thus, sin of theta is equal to plus minus 1 by under root 2. Now, 3 into pi by 2 less than theta less than 2 into pi implies that theta lies in the fourth quadrant. That means sin theta is negative. Sin of theta is equal to minus 1 by under root 2. Tan of theta is equal to sin of theta by cos of theta is equal to minus 1 by under root 2 upon 1 by under root 2 is equal to minus 1. Cot of theta is equal to 1 by tan of theta is equal to minus 1 and cosec of theta is equal to 1 by sin of theta is equal to 1 by minus 1 under root 2 is equal to minus under root 2. Now, 1 plus tan of theta plus cosec of theta by 1 plus cot of theta minus cosec of theta is equal to 1 plus minus 1 plus minus of under root 2 by 1 plus minus 1 minus of minus under root 2 is equal to minus of under root 2 by under root 2 is equal to minus 1. Example. If theta is the positive acute angle, solve the equation 4 cos square of theta minus 4 sin of theta is equal to 1. Solution. 4 cos square of theta minus 4 sin of theta is equal to 1, or 4 into 1 minus sin square of theta minus 4 sin of theta is equal to 1, or 4 sin square of theta plus 4 sin of theta minus 3 is equal to 0, which is a quadratic in sin of theta. Sin of theta is equal to minus 4 plus minus under root 4 square minus 4 into 4 minus 3 by 2 into 4 is equal to minus 4 plus minus 8 by 8 is equal to 1 by 2 or minus 3 by 2. As sine of theta is less than or equal to 1 numerically, hence the value of sine of theta is equal to minus 3 by 2 is not possible. Therefore, sine of theta is equal to half is equal to sine of 30 degree. So, theta is equal to 30 degrees. Example. Find the values of the other 5 trigonometric functions if tan of theta is equal to 3 by 4. Theta in quadrant 3. Solution. Theta lies in third quadrant, and in third quadrant, tan theta and cot theta are positive, and sin theta, cos theta, sec theta and cosec theta are negative. Tan of theta is equal to 3 by 4. This implies that cot of theta is equal to 1 by tan of theta is equal to 4 by 3. Sec square of theta is equal to 1 plus tan square of theta is equal to 1 plus 3 by 4 whole square is equal to 1 plus 9 by 16 is equal to 25 by 16. This implies that sec of theta is equal to minus 5 by 4. That means cos of theta is equal to minus 4 by 5. Sin square of theta is equal to 1 minus cos square of theta is equal to 1 minus 16 by 25 is equal to 9 by 25. This implies that sin of theta is equal to minus 3 by 5. That means cosec of theta is equal to minus 5 by 3. Trigonometric functions of sum and difference of two angles. Addition formula are difference formula are some important results are extraordinary approaches are example. Prove that sine of 75 degree is equal to under root 6 plus under root 2 by 4. Solution. Sine of 75 degree is equal to sine of 45 degree plus 30 degree. That is, sine 45 degree into cos 30 degree plus cos 45 degree into sine 30 degree. By solving it, we get under root 6 plus under root 2 by 4. Example. Find the values of cos of 15 degree. Solution. Cos of 15 degree is equal to cos of 45 degree minus 30 degree. That is equal to cos 45 degree into cos 30 degree plus sin 45 degree into sin 30 degree is equal to 1 by under root 2 into under root 3 by 2 plus 1 by under root 2 into 1 by 2 is equal to 1 by under root 2 into under root 3 by 2 plus 1 by 2 is equal to 1 by 2 under root 2 into under root 3 plus 1. Trigonometric equations. Equations involving trigonometric functions of a variable are called trigonometric equations. The solutions of a trigonometric equation for which 0 less than or equal to x lies than 2 into pi are called principal solutions. The figure given below shows the trigonometric equations. Theorem 1. For any real number x and y, sine of x is equal to sine of y implies x is equal to n pi plus minus raised to the power ny, where n is any integer. Theorem 2. For any real number x and y, cos of x is equal to cos of y implies x is equal to 2n pi plus minus y, where n is any integer. Theorem 3. If x and y are not odd multiple of pi by 2, then tan of x is equal to tan of y implies x is equal to n pi plus y, where n is any integer. Example: solve 2 sin x minus 1 is equal to 0 for x is equal to 0. Solution: we can solve for sin x using our methods from algebra. We will then use our knowledge of trigonometry to find x itself. 2 sin of x minus 1 is equal to 0. 2 sin of x is equal to 1. Sin of x is equal to 1 by 2. Sin x is equal to 1 by 2. The reference angle for x is 30 degrees, as 1 by 2 is a positive number and the sine function is positive in quadrant 1 and quadrant 2. X must be 30 or 150 degrees. Did you know? The trigonometric functions sine and cosine were introduced by the famous mathematician Aryabhat. The angles have the same position of initial ray and terminal ray. Such angles are called coterminal angles. Sine, cos and tan are not multipliers. Summary. Let us summarize what we have learned. Angle is a measure of rotation of a given ray about its initial point. Radian measure is equal to pi by 180 degree. Degree measure is equal to 180 by pi radian. Sine square of theta plus cos square of theta is equal to 1. Sec square of theta is equal to 1 plus tan square of theta. Cosec square of theta is equal to 1 plus cot square of theta. In the first quadrant, all are positive. In the second quadrant, sine and cosec are positive. In the third quadrant, tangent and cotangent are positive. In the fourth quadrant, cosine and secant are positive. Equations involving trigonometric functions of a variable are called trigonometric equations.